Hi everyone, Mrs. V here, and today we are going to be talking about the reaction of acids with metal carbonates and metal hydrogen carbonates. So this is the last of our double replacement reactions that we're going to be talking about. So let's get straight down to it. You'll remember that acid reactions are dependent on which acid you use as to which salt you get. Now, the acid metal carbonate reaction is another type of double replacement reaction where we need to remember that hydrochloric acid makes chloride salts, sulfuric acid makes sulfate salts, and nitric acid makes nitrate salts, etc., etc. So you'll remember we talked about in our last video the fact that that's because all acids release H+ when you put them in water. So they all do the same type of reaction. So today we are looking at the reaction of acids and metal carbonates. So let's have a look at the reaction between sulfuric acid and calcium carbonate and look at it as a double replacement reaction. And we're going to see if we can work out what is produced in this reaction. Well, if it's a double replacement, then we would expect the hydrogens and the carbonates to get together, and then the calcium and the sulfate to get together. So we would expect our reaction products here to be calcium sulfate and H2CO3, which is carbonic acid. Now, we do observe this. However, what we see is that this carbonic acid breaks up further into water and carbon dioxide. And so when we react acids and metal carbonates, then we get our metal salt, water, and carbon dioxide formed. So here's our general equations. It doesn't matter if it's a hydrogen carbonate or a carbonate, you get the same products. The hydrogen carbonate ion is simply a hydrogen ion and a carbonate ion combined. And so we get HCO3 and a single minus because the plus charge of the hydrogen cancels out one of the negative charges of the carbonate. All right, let's have a look at some examples. We're getting into this idea of predicting products, so I want you to have a go straight away. Use the general equation to predict what's going to happen in the reaction between nitric acid and zinc carbonate. Pause the video, we'll be back with the answer. All right, so we would be expecting to get a metal salt. Our metal here is zinc, and nitric acid will make nitrate salts. And then we always get water and carbon dioxide produced as well. To write a balanced chemical equation for this, we simply need to start with writing out the correct formula for everything that's in the equation. So we're going to start with nitric acid, which is HNO3. How are you going at remembering your acid formulae? Then zinc carbonate. Zinc is a transition metal, but it can only take the valence of 2. So zinc will always form a 2+ ion. And that's why even though it's a transition metal, it doesn't end up getting a Roman numeral because it's always 2+. So there's no ambiguity. We don't need to point that out. The carbonate ion is CO3 2-, which means it has a valence of 2. So it will match up 1-to-1 with the zinc, and the formula of zinc carbonate will be ZnCO3. In the products, zinc nitrate, again, zinc is a 2+ ion. The nitrate ion is NO3-, which means it has a valence of 1. So we're going to need 2 of those nitrate ions for every zinc. So zinc, and remember to put the nitrate ion in brackets because it's polyatomic, gives water and carbon dioxide. At this point, we have to do our elements inventory to check whether our equation is balanced. So what do we have? We have hydrogen, nitrogen, oxygen, zinc, and carbon. Let's do that on the other side as well. Hydrogen, nitrogen, oxygen, zinc, and carbon. All right, let's do our tally. So we can see on the left-hand side, we have one hydrogen in the nitric acid, and that's it. We have one nitrogen in the nitric acid. Oxygens, we've got 3 in the nitric acid, and we've got 3 in the zinc carbonate, so that's 6 altogether. Zinc, we have 1 in the zinc carbonate, and carbon, we have 1 in the zinc carbonate. On the right-hand side, let's tally our hydrogens. We have 2 in that water. We have 2 nitrogens in the zinc nitrate because we've taken the nitrate ion twice. Oxygens, we have 6 in the zinc nitrate, 2 3s, plus another 1 in the water, plus 2 more in the carbon dioxide, so that is 9 altogether. We have 1 zinc and we have 1 carbon. Now we need to look at balancing anything starting without oxygen and hydrogen. We always leave oxygen until last and hydrogen until second last. So I can see what's out of balance now is the nitrogen. So I have 1 nitrogen on the left and 2 on the right. So I'm going to need to double up the nitrogen containing compound on the left. That's going to give me now 2 hydrogens, 2 nitrogens, and now altogether I'm going to have 2 3s are 6 oxygens in the nitric acid plus another 3 in the zinc carbonate, makes 9. And just like that, our equation is balanced. All right, let's move on. Let's do a hydrogen carbonate example. Hydrochloric acid and aluminium hydrogen carbonate. Now this is going to be a good one. So first of all, I want you to predict the products. So pause the video, tell me what will form. Okay, so acid plus metal hydrogen carbonate will give a metal salt. The metal this time is aluminium. And hydrochloric acid gives us chloride salts. And then plus water plus carbon dioxide. Now, I want you to pause the video again and I want you to write the correct chemical formula for everything in that equation. We'll be back with the answer. Okay, so hydrochloric acid is HCl. Aluminium hydrogen carbonate. Aluminium is 3+ and hydrogen carbonate is 1-. So we're going to need 3. Aluminium chloride, again, aluminium is 3+ and chloride is 1-. So it's AlCl3 plus water plus carbon dioxide. Now this is a bit of a tricky equation to balance, but if you persist, then you're going to get there. So I want you to pause the video and have a go. I'll come back with the answer. All right, elements inventory. Hydrogen, chlorine, aluminium, carbon and oxygen. Let's do our count. On the left-hand side, hydrogens, we have 1 in the hydrochloric acid and we have 3 in the aluminium hydrogen carbonate, so that's 4 altogether. Chlorines, we just have 1 in the hydrochloric acid. Aluminiums, we just have 1 in the aluminium hydrogen carbonate. Carbons, we have 3 of those in the aluminium hydrogen carbonate. And oxygens, we have 3 3s are 9 in the aluminium hydrogen carbonate. Over on the right-hand side, oh, we didn't write water as H2O. That was a bit, we might fix that up. Okay, H2O, that's better. Now we have 2 hydrogens in the water. We have 3 chlorines in the aluminium chloride. We have 1 aluminium in the aluminium chloride. We have 1 carbon in the carbon dioxide. And we have 1 oxygen in the water and 2 in the carbon dioxide, so that's 3. Now this looks like an almighty mess, but remember, leave oxygen and hydrogen until last, focus on the others. So let's go with chlorine first. We've got 1 on the left and 3 on the right, so we need to have 3 lots of the chlorine containing compound, and that is going to give us our 3 chlorines, but it's also added to the hydrogen count. So now we've got 3 hydrogens in the HCl and 3 in the aluminium hydrogen carbonate, so that's 6 altogether. Now, what else do we have? We have the carbon that we need to balance. So we have 3 carbons on the left and only 1 on the right. So we're going to need to treble the carbon dioxide, and that's going to give us our 3 carbons, but it's also changed our oxygens. So we have now 3 2s are 6 in the carbon dioxide, plus 1 is 7. All right, we have no choice now. We have to go to hydrogen. So we have 6 hydrogens on the left and 2 on the right. So we're going to need to treble the water to bring us up to 6 hydrogens here. That's also changed our oxygen count though. So now we have 3 in the water, plus 3 2s are 6 in the carbon dioxide, so that's 9. And then just like magic, the equation is balanced. If you found that explanation useful, then please give the video a like and consider subscribing to the channel so that you can get more great chemistry advice. I am going to see you guys in the next video.